in the diagram, AB is equal to x, BD is equal to 2x plus 6y, and CD is equal to 2y. Express in terms of x and y in simplest form, the vector AD. And so here we have AD, and AD means that we start at A and we end at D. So we're gonna go from A to B, and then we go from B to D. And so what do we have? Well, AD is equal to, if we go from A to B, that's x. And if we go from B to D, that's 2x plus 6y, as we have here 2x plus 6y. And so what we can do is we can add these two terms because they are like terms. So we have x plus 2x, and x plus 2x is definitely equal to 3x. And so again, x plus 2x is 3x. And so we have 3x plus 6y. What we can do is we can factor out a 3. So we can put the 3 out front. And so 3 times x is 3x, and 3 times 2y is 6y. And so we factored out a 3. And so AD is equal to 3 open bracket x plus 2y. Okay, next we have BC, right? So we have the vector BC. Now, if we have the vector BC, BC means that we start at B, right? That's what BC means. BC means that we start at B and we end at C. That's what BC means. We start at B and we end at C. And so we go from B to D and from D to C. So BC means that we go from B to D, and BD means what? 2x plus 6y, which we have here, 2x plus 6y. And D to C is negative 2y. Now, why is it negative 2y? It's negative 2y because we are going in the opposite direction, right? Right, so we're going in the opposite direction. Notice that 2y is from C to D, but we're going in the opposite direction from D to C. So since we're going in the opposite direction, it's not going to be 2y, but it's going to be negative 2y. And so we have 6y minus 2y, and 6y minus 2y is equal to 4y. And so BC is equal to 2x plus 4y. We can factor out the 2. And so we have 2 on the outside. And then on the inside, we have x plus 2y. So we have 2 times x, which is 2x. And we have 2 times 2y, which is 4y. And so that's what BC is. BC is 2 multiplied by x plus 2y. Okay, next, they want us to write two geometrical properties of A and D. They want us to write two geometrical properties of AD and BC. And so they want us to write two geometrical properties of AD and BC. Now, notice carefully that we figured out before that AD is equal to 3 times x plus 2y. And we figured out before that BC is equal to 2 times x plus 2y. So we have these two vectors here. Now, what we can do is we can take AD and we can express it as, we know that AD is equal to this, but we could express it in a different way, but it still is equal to the same thing. And the reason why we want to express it in this way is because it's going to emphasize, or it's gonna help us to see things that we probably would not see if we didn't express it in this way. So I'm gonna write AD, the same AD, but I'm just gonna write it in a different way. And so this is the way that I write AD. Now AD is equal to 3 over 2 multiplied by 2 open bracket x plus 2y. Now these two are equal. Now you may say, well, how are they equal? But they are equal, and we know that they're equal because all we need to do is we need to cancel out this 3. I mean, we need to cancel this 2 with this 2. And if we cancel this 2 with that 2, we left with 3, right? Multiplied by x plus 2y, all right? And that's exactly what AD is, 3 multiplied by x plus 2y. And so what does that mean? That tells us that these two expressions are actually equal to each other, right? So we can express 3 open bracket x plus 2y as 3 over 2 all multiplied by 2. So we can express AD, which is 3 open bracket x plus 2y, as 3 over 2 multiplied by 2 open bracket x plus 2y. And we know we can do that because all we need to do is cancel these two 2's, and then we left with 3 open bracket x plus 2y. Now, why would we express this like this? Well, the reason why we express AD in this form is because if we notice carefully, what do we have in red, right? What do we have in red? Well, what we have here, we have this 2 open bracket x plus 2y. That's exactly BC, right? That's exactly BC. These two are the same thing. And so these are the same thing. So that means that instead of writing 2 open bracket x plus 2y, instead of writing that, I can say 3 over 2 multiplied by BC, right? And so that means that AD is equal to 3 over 2 BC, all right? And so that makes sense because AD is equal to 3 over 2 BC. Now that's important because this result is important because since AD is equal to 3 over 2 BC, we have certain things that follow, that follow as a result of us knowing that AD is equal to 3 over 2 BC. Now, what does this mean? Well, this means that we can take BC multiplied by 3 over 2 and we get AD, all right? So what follows as a result of this, of us understanding that AD is equal to 3 over 2 BC? Well, the first thing that we know is that the vectors AD and BC are parallel to each other. Now we know that they are parallel because we can take one vector multiplied by a scalar, and that gives us the other vector. And so since these two vectors are scalar multiples of each other, they are parallel. That's what it means for two vectors to be parallel. It means that there exists a scalar that we can use to multiply one vector by that scalar and give us the other vector. That's what it means. That's literally what it means to be parallel. Two vectors are parallel if there exists a scalar that we can use to multiply one vector with to give us the other vector. And so since these two vectors are scalar multiples of each other, it means that they are parallel. So one, the two vectors AD and BC are parallel. The vectors AD and BC are scalar multiples of each other, which and these two mean the same thing. And the vectors AD and BC have the same direction. We know that they have the same direction because 3 over 2 is positive, right? It's not negative. And so they are going in the same direction. And vector AD is 3 times, and vector AD is 3 over 2 times longer than vector BC. Now they only ask us for 2 geometrical properties. And so if we were to use 2 geometrical properties for this answer, I would say choose this one and this one. So you can say that the vectors AD and BC are parallel, and you can say that vector AD is 3 over 2 times longer than vector BC. All right. Okay, and that's the answer to this question.